So to start off Unit 6, which is our final statistics unit, we are going to just look at some definitions. So these should be definitions we're pretty familiar with, so I'll go through them quickly. The mean is just our average of a set of numbers. So the mean is our average of a set of numbers. So what I do for my mean is I add up all the data points and divide by the total number of data points. What we use to represent mean is X bar or mu. Those are just ways of saying, okay, my mean is whatever it ends up being. So we use this X bar and we use this mu. This is just a Greek letter. Our median is the middle value of a set of ordered numbers. So the key part in this definition is that the numbers are in order from least to greatest. So it's the middle value of a set of ordered numbers. Those are ways that we represent the center of a data set. So it's one of our measures of center. We've got mean, and another measure of center is our median. It's a way to generalize data sets. Another way we can describe data sets is the measures of spread. So how much does each data value vary from the others? So we're just saying describes the variance of data values. So how different are they from each other? We know that the range is the difference between the largest. So it is the difference between the largest value and the smallest value in a set of data. So this is what we're used to looking at when our numbers are already ordered from the median. I can easily see my biggest number and my smallest number, and when I subtract those, I get my range. Another type of range that's important to represent the variance or the spread of our data set is the interquartile range. So this is actually, if you're looking at your percents of data value, so if I have a really big set of data, this is super helpful. I can see how large the span is of my middle 50%. And hopefully this is easier when we look at the visual representations of data later on in this video. So our interquartile range is the difference between, I probably won't have space to write all this in this one line, the smallest value and the largest value of the middle 50% of the data. So what we call the first 25% is the first quartile. So I'll write this in like a lighter blue. So this is the lowest 25% of the data. And then this is the highest, the greatest 25%. We have another measure of spread that is called the mean absolute deviation. So this is more intimidating than it actually is, especially when I show you what the formula is. But before we write the formula, I will write the definition. So it's the average distance between each data point and the mean. So the way that this is represented, and again, this is going to look a lot scarier than it actually is we have the MAD, so the mean absolute deviation, MAD, is equal to the summation, which we use this fancy E symbol, of each data point. So each data point is represented by the letter X and then its subscript minus the mean. I'm going to use the little X with the line on the top like we talked about before, divided by the total number of data points. This is just the mathematical way of saying this definition. So don't let this formula scare you, because all this is saying is that the mean absolute deviation is just the average number of the distance between each data point and the mean. The standard deviation is essentially the exact same thing, except for instead of it just being the absolute value of the difference, you're going to take the square root of it being squared. So the standard deviation is just like the mean absolute deviation. It's a measure of the distance between each data point and the mean, but we're going to just be a little bit more precise by taking the square root of the summation of each data point's distance from the mean squared and divide it by the total number of data points. So these are super, super similar ways of measuring the spread of the data.